Assalamualaikum. My name is Anwar. I'm the number 07185, and this is our project presentation from G15 with the title Predicting Employee Attrition using IBM HR Analytics Data. Now, this is our group member for group history. Here you got myself, Dr. Anwar, Muhammad Faiz bin Ahmad Najib, and Muhammad Hanan Ahmad bin Sugiman. The short intro to our project is that the objective of the study is to predict employee attrition using HR data. And the data set used is IBM HR Analytics, employee attrition and performance that is sourced from Kaggle. The dataset includes features such as employee details, such as education, job roles, salary, satisfaction, and more. Now, to move on to technique evaluation, we got three types of technique that we can possibly employ in our dataset. Firstly, the classification. The purpose of it is to predict the categorical outcome. For example, the attrition features that we're trying to predict with the binary output, which is yes or no. The dataset compatibility for this technique is very high, and it aligned with our purpose or objective for the project, which is to predict the attrition. So its best use case is the building predictive model, so identify at-risk employees. Secondly, the clustering. The purpose of clustering is to group similar data points without predefined labels. And the dataset compatibility is moderate and it's not useful because it cannot directly predict attrition, but can reveal hidden patterns instead. So it does not align with our objectives. The best use case is to segment employees based on behavior or risk level for further analysis. And lastly, the statistical analysis is find relationships, trends, and distributions. The dataset compatibility is moderate. Unfortunately, it is not aligned with our objective, which is to predict the attrition status of an employee. So we have not chosen it as they have no predictive capability but supports insight generation. It's best used when we need to understand key factors that correlate with public for informed decisions. And in summary, classification is the most suitable technique for this project due to the binary nature of the target variable. Clustering and statistical analysis offer valuable supporting insights, but does not fulfill the primary goal of predicting. Now, what each technique influence in decision making. We're going to look at the design produced from each technique and the influence that it can bring when making a decision. For classification method, can predict the likelihood of an employee leaving, which is the attribute as possible, and the influence means that it can enable early intervention strategies like pension bonuses, flexible work, options, or surveys. The second method, clustering, includes employees with similar attrition-related patterns, e.g., low satisfaction. And what we can do with that insight, we can help design retention-focused strategies for at-risk clusters, such as improved benefits. And our final technique, statistical analysis, the insight produced from this technique is that can identify factors strongly associated with attrition, e.g., the overtime or the role type. What we can do with this, we can inform the HR about key risk indicators shaping general HR policies and awareness campaigns. All in all, the objective of the project is to predict the attrition of an employee. Thus, the method classification is the best one you can use for this project. And now, lastly, the model evaluation for classification technique. We got three models. The first one is a logistic integration. The strength of logistic integration is it is fast, simple, interpretable outputs probabilities. And limitation of it is limited to decision boundaries and very sensitive to audience. The best use case for this model is express probability classification with linearly separable data. Logistic integration is fast, efficient, and easy to interpret, making it ideal for simple, linearly separable problems, but it may not perform well on complex non-linear data. Our second model that we will evaluate is called random forest. The strength of random forest is its robust omniscient, handles non-linear relationships well, works well with mixed data type. The limitation of this model, though, is it is computationally expensive and harder to interpret. The use case for this is it is ideal for complex data sets with many features. Random forest is a robust model for complex, high-dimensional data sets, but it takes slower and harder to interpret the output. And lastly, our final model evaluation is the k-nearest neighbors. We call it KNN for short. The strength of it is simple, it's flexible for non-linear boundaries. The limitations of it is slow with large data sets, sensitive to noise and relevant features. The use case for this is best for small data sets with complex relationships. KNN is useful for small data sets where relationships between features are complex and non-linear, but it may not scale well with larger data sets. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanan Ahmad bin Sugiman. My mentor number is 07335. Let's continue with the importance of pre-processing. Pre-processing is about cleaning and organizing the raw data set so it's ready for machine learning. In our project, we work with different type of data like categorical, continuous, and ordinal, and apply the right method to each. We convert categorical features like business travel and job role into number using one hot encoding so the model could understand them. For continuous values like age or monthly income, we group them into range to reduce noise. Ordinal features such as job level were kept in order so their rank still makes sense. We also remove unnecessary column like employee number and focus only on the features that help improve the model. Okay. Now moving on the feature selection. This step is all about keeping the most important variables that influence whether an employee will leave. We select the features like job satisfaction, overtime, work-life balance, and total working years because these are directly linked to employee decision to real life. By doing this, the model became not only more accurate but also easier to understand and faster to train. Now let's talk about how all of this impact model performance. Thanks to pre-processing and good feature selections, the model gave better predictions. That's accuracy. It also performed more consistently with new data. That's reliability. And since we use clear and logical features, HR managers can understand and trust the model's prediction. That's interpretability. Good. Speaking of real-world impact, this kind of model can actually help HR team take action. For example, they can spot employees who might need support or better manage promotions and training. But this only works if the model is clean, fair, and free from bias. That's why careful pre-processing and ethical feature selection is so important. Okay. Finally, here are the steps that affect our model. We start with categorical pre-processing, converting features like job role and department into binary form. It improves accuracy by providing clean numerical inputs, enhance reliability by standardizing the structure, and supports interpretability, making the result more understandable and relevant in an HR context. Okay. Then we process continuous data like age and how you rate by grouping value into range. It improves accuracy by reducing the effect of outliers, increase reliability by standardizing value range, and supports interpretability by turning raw numbers into understandable means that HR can relate to real employee situation. Okay, and in the last steps, we use the select column tools to keep only the features that matters, improving accuracy and making the model simpler and clearer for HR to use.
Yeah, Assalamualaikum. Now we move on to justification for this project. So the first thing is we identify the step. So the first step is understand the stakeholder needs. We identify what the HR managers, executive, and employees expect from the models. Second is we ensure high data quality. We prepare the data set to be ensure it is clean, consistent, and unbiased, because poor data leads to misleading and unfair models. Third is we focus on model transparency and explainability. We make the forest model and other two model interpretable to non-ethical stakeholder, and so we could translate complex result into understandable insight. And lastly, we robust model evaluation. We evaluate model accuracy and performance using reliable metrics. Prove the model is both accurate and reliable. Second, for the justification is ethical consideration and potential challenges. First step is bias and discrimination. If the model is inadvertently discriminate against the certain group, such as older employees, it could lead to unethical decision and legal issues. Second is privacy concern. Employee data is sensitive, so data must be handled securely, and prediction should not be used in way to violate individual privacy. Third is transparency and consent. Employees should be aware if their data is used in predictive models, and transparency should be maintained in how the model impact decision. And last step is over-reliance on automation, where decision making should not be fully delegated to the model, and human oversight is necessary to contextualize prediction and ensure the ethical outcome. Now we move on to result and impact. As you can see, we use lot of continuous float data and single digit continuous, and we use three model, which is first random forest, logistic regression, and KNN. And now we could see the data for the result of data for the three model, random forest, logistic, and KNN. And here are all the labels of each attribute that we use in this dataset. As the conclusion, identifying and addressing this potential source of error is crucial for ensuring quality and reliability of collected data in research or data collection effort. Regularly reviewing and improving data collection methods can lead to more accurate and meaningful results. That's all from us. Thank you.